Hello, everyone. My name is Laura Villalobos. I'm WiCyS Community Manager, and I would like you to welcome you to this WiCyS webinar with Joylynn from Microsoft on the topic of Shift Happens, how to deploy DevSecOps principles in development of life cycles. But before we start, I'd like to introduce a little bit about the WiCyS organization. We all have our wonderful initiatives to our strategic. We often go by our acronym WiCyS as in we sisters because that's exactly who we are, a global cyber sisterhood. We are a 501c3 with over 7.5 members in 70 countries. WiCyS is a premier organization with global reach dedicated to bring together women in cyber. Our mission is to recruit, retain, and advance women in cybersecurity. All of our programs and initiatives are made possible by our supporting strategic partners such as Microsoft. We have our professional affiliates, student chapters, equity advocacy committee, mentor-mentee program, speakers bureau, job board, and so much more. You can view our training programs and initiatives on our website at WiCyS.org to learn more about the different ways to get involved beneath the WiCyS community. We all offer wonderful initiatives to our strategic partners, our tier one partners being Akamai, Amazon, Battelle, Bloomberg, Carnegie Mellon University Software Engineering Institute, Cisco, Fortinet, Google, Lockheed Martin, Meta, Microsoft, Optum, India National Labs, and SentinelOne. Reminder to ask questions throughout the webinar. You can put them in the chat and the presenter will answer them at the end. We have the expert here with us today and we look forward to hearing from you. If you haven't done so already, be sure to subscribe to the WiCyS newsletter at WiCyS.org to stay up to date on any upcoming WiCyS events and trainings. And with us today, we have Joylynn from Microsoft on the topic of Shift Happens on how to deploy DevSecOps principles in the development of the lifecycle. So I'll hand it off to her to take it off.
Thank you so much. Maybe before you leave, Laura, do you know anything around DevSecOps? Or have you covered anything around DevSecOps before?
I have not, no.
Okay, so it's good. So at least we can start from sort of beginning, and then I hope we'll have a lot more questions from the audience. Thank you, Laura. So we'll kick off the discussions. I'll kick off with a brief introduction about myself. My name is Joylynn Kirui. I'm a senior cloud security advocate at Microsoft, and I focus on DevSecOps and application security. I'm based out in a country called Kenya in Africa, and I am a global advocate, as you can see. So I cover everywhere. And today we're going to talk about shift happens, because when you are breached, when security breaches happen, shift happens for sure. So we're going to see how we can be able to deploy DevSecOps principles, so at least to prevent shift from happening. So we'll just start off with a brief statistics, because this is very worrisome. So you'll find that 52% of companies actually sacrifice cybersecurity for speed. So this is it. So you'll find that there's a scenario whereby the business wants to deploy a particular feature by end of next week, Friday. So imagine a scenario whereby on Thursday, you discover a critical vulnerability, which actually would need the whole solution to be built afresh. Yes, I've seen that happening before. So what happens in such a situation? Do you sacrifice cybersecurity for speed? Because they've already promised the shareholders that this particular product actually go to production. So what happens in that case? So we've seen a lot more companies actually prefer to push speed, even if there are cybersecurity vulnerabilities in place. And then you'll find that 57% of ops team actually push back on security best practices. For sure, I have seen this before, whereby they find that I've been guilty of this before, whereby you just generate like a whole list of security vulnerabilities, and then you give over to the developers, and then you also give over to operations teams. And then you tell them that this particular application that you are hosting within your environment is actually vulnerable. You need to upgrade to the latest version. You can imagine if you're using legacy systems which actually take months to upgrade or to even update. So yes, so there's a lot of pushback between operations teams and security teams in this case. And for developers, we find 44% of developers are not yet trained to code securely. And I usually say developers are actually our first line of defense. So you can imagine if you're not training our first line of defense in secure coding, then you're introducing security vulnerability from the word go. So what are we going to do about it? Let's just talk a little bit about code in general. So you find that actually this is a very interesting one. Like 80 to 90% of code that you actually build and deploy is borrowed code, what we call like open source code or third-party components. And then what you actually code is very minimum. You can see here on this chart, the new code is very small percentage. So you can imagine if you don't know the security vulnerabilities within the 80 to 90% of the code that you're borrowing, you're actually introducing security vulnerabilities within your environment. And for sure, we're seeing that we have actually like 100 to 1 developers to security professionals. So we can't actually be overwhelmed for sure. And there's usually a huge demand for security professionals. There still is. These are a very lucrative profession, and AI won't take over our jobs for sure. Because the way I'm saying it, like there's still a need for us to even do AI security to assure everything around end to end. And we need a lot more people for sure. So if you have 570 times more developers than security researchers, so what happens? So there is a gap right there. So what do we do with that? We'll discuss that a lot more in the coming slides as well. So with the 80 to 90% of dependencies or unchecked dependencies, borrowed code, open source code, third-party components, what other vulnerabilities do we see? We see actually employee errors, because we've seen that 44% of developers are actually not trained on security best practices. That's how they're introducing employee errors. They're hard coding credentials. They're leaving API tokens. They're leaving secrets within the code base, or even not deploying using the best practices. So here we have employee error, which is also there on the top. And this damage is usually exponentially more when the breach happens when it's in production compared to development. So that's why we have to shift left, what we call DevSecOps. So DevSecOps in general is whereby we are deploying security, automation, and best practices throughout the software development lifecycle. So there are very many importances of like why we need to shift security left. So you will actually find that you have 80% less security incidents during development because you are addressing them as early on as possible. And then the cost is exponentially lower when you discover them during the development lifecycle, development phase in comparison to production. So you can see that it's 6 times cheaper to fix security vulnerabilities during development. And for sure, 62% of enterprises do not integrate security during the development phase. That's why we have to talk about this as much as possible to make sure that everyone is deploying security automation, and the developers actually even trained from the word go on having a security first mindset. So this is how security fits within the development lifecycle. So feel free, if you have questions, you can ask on the chat, and then we will answer them as we go. So this is how security fits within the development lifecycle. As you've seen, we usually have the pre-commit, and then the commit, and then the deploy, and then when you deploy, you make sure that it's operating well and it's monitored. So for sure, security has to be incorporated throughout all these stages. So for all of the organizations, you have to make sure that you have security standards set in place, whereby at least the developers are using them on a day-to-day practice. And it's also good to have training sessions for the developers every so often. How I usually like doing it, like for even previous organizations I've worked at, I train them on secure coding best practice at least once a month. And then you also give them like a platform for doing security challenges. So at least they can also address and learn how they can be able to remedy the security vulnerabilities that they have identified. Another key component that they have to do is threat modeling. Threat modeling is whereby at least you're trying to draw the threat vectors that can be used to compromise your system, like virtually before actually going into the coding. So this is whereby at least you are sort of brainstorming. You're seeing that yes, you're going to use all these APIs. These are the endpoints that will be public facing, so the ones that will be private. So what can we do to make sure that the public endpoints and the private endpoints as well are secure? The reason why I'm saying the private endpoints as well, because you never know. You find that there are also disgruntled employees here and there. They can even use the insecure private endpoints to compromise you, let's say APIs as well. So this is also where we have to train on IDE security plugin. I'll also show you how to do that later on. So at least you can be able to identify security vulnerabilities from the word go. Whenever a developer is coding, they are able to find security vulnerabilities on the go. So at least they can fix them before actually pushing the code. And then we'll have pre-commit hooks, which even prevent, if you have secrets within your code and it identifies that you have secrets, it won't allow you to commit your code. We also have peer review. It's best practice to have peer review and also peer programming as well. So at least you have someone else to check your code for issues, not only security vulnerabilities, but also if you've deployed best practices. And then for the threat modeling, I would recommend you to go in and search for the Microsoft Threat Modeling tool. It's a great tool for you to go in and just draw the threat vectors within your application and see how you can be able to secure them from the word go. So here you're trying to see what vectors can be used by the attacker to compromise your system, and try as much as possible to put in the security best practices from the word go, from requirements gathering. And then we go in to commit. So here we look at something called static application security testing. So static application security testing is your code is already probably in a repo. We want to scan it for security vulnerabilities, and then it will give you vulnerabilities. So we'll also look at that during the demo. We also have security unit tests. Security unit test is very important because you can imagine a scenario whereby, I'll give an example of what I've done before. You have an e-commerce website and someone is able to proxy the requests and change the request from the client. And probably if you are buying, let's say, Diet Coke, and then you change the value from, let's say, $1 to a few cents or even nothing. So if the server side accepts that request, that means that they don't have any form of validation. So these are some of the security unit checks that we do to make sure that the checks are doing what it's supposed to do securely. We also look at dependency management, or what you call also software composition analysis. So software composition analysis, remember we mentioned that 80 to 90% of code that we use is actually borrowed code. So it also comes in with a lot more security vulnerabilities. So we have to make sure that the dependencies that we're using are all secure. I usually give this reference. So for us, we have to be lucky throughout, and the hacker has to be lucky only once for them to compromise your system. You can imagine how we have to do a lot more work to make sure that our systems are actually secure. And that also entails having supply chain security. I'll also cover a tool by Microsoft called the S2C2F. which covers the best practices for supply chain security, which can be able to deploy according to where the level of your organization is. We also have credential scanning. So credential scanning checks your code for any exposed secrets and hard-coded credentials, tokens, and lets you know that you need to fix them as soon as possible. So it's very important to identify the credentials even before you commit them. Here's why: because if you leave your code and then you've put them even in a public repo, it will still remain in the history. Even if you fix that particular security secret, if you go back to the previous versions, you'll be able to see the password that was actually corrected. Not unless now you go back and make sure that all of it is actually removed. And many people don't go back and remove all those secrets that were actually exposed. And when you go to deploy, here we look at infrastructure as code. We are trying as much as possible to deploy your infrastructure through means of code. So if you want to spin up an Nginx server, you can be able to spin it up as code. If you want to deploy, let's say, a Windows VM, you should be able to do that as code. Maybe there's an ARM template for that. For ARM templates, we'll make sure that you have to use templates that are already secure. Or if you're using a new template, make sure that you're also integrating security tools to scan your infrastructure for security vulnerabilities. We also cover that later on during the demo. And we also have dynamic security scanning. So once you've committed your code and it's already running, so you have to make sure that this application is already running, let's say in a staging environment. You have to do like dynamic security checks against the code that's already running. So the difference between dynamic security scanning and static application security testing is by this one will be able to fuzz a lot more. And even it will be able to try and break. It will throw a lot more requests on the application to see if it will break, to see if it has, let's say even remote code execution vulnerabilities, if it has SQL injection vulnerability, so it will be able to push a lot more requests to the server or the application. So here we also look at cloud configuration checks to make sure that you have configured your infrastructure and your cloud environment securely. And then we do security acceptance tests just to make sure and confirm that all the security checks are done appropriately. And then after you've done all that and you're comfortable with the level of security, you can be able to now deploy and now make sure that you are monitoring it. So let me just say this, there's nothing that is 100% secure. If someone tells you that this system is 100% secure, that's a lie. And that's why we have to do all these security checks just to make sure that everything is, we make it very difficult for a hacker to compromise your system. So this is also where we look at like defense in depth, whereby you're putting layers and layers of security on infrastructure just to make sure that if a particular layer was actually compromised, they don't access like your VM directly. They don't access your resources directly. So you make it very hard for them to compromise. And fun fact, it takes 3 days for a vulnerability to be exploited. So our target is to make sure that you address security vulnerabilities before 3 days elapse. The sooner, the better. And then during the operate and monitor, have to make sure that you're doing continuous monitoring, because remember we have to make sure that you're doing continuous monitoring, threat intelligence, and blameless postmortems, because remember we have 0-day vulnerabilities as well. With the 80 to 90% of code that you've actually borrowed into your environment, we have 0-day vulnerabilities, even with the code that you're actually building. So what happens? You have to make sure that you are keeping in touch with the security news and knowing which components that you're using within your environment is actually vulnerable. So this is where we also talk about having an SBOM, having a software bill of material, and having an inventory of all the security components that you're using. So at least when it goes by that a particular component, let's give an example, like for the Log4Shell vulnerability, many people did not know like the number of components that had that particular vulnerability. But if you have an inventory of all the components that you're using within your organization, it will be very easy now for you to go in and patch all of them. So we'll just dive a little bit around here for static and dynamic analysis. This is very important. So is where we're looking at your security review for your code. For static, remember we said it's dormant code, so it's code that's not running. So you have to go in and make sure that it has security vulnerabilities fixed before production. And then dynamic analysis, whereby you are running your code, your security checks against code that's already running. So one such tool that you use for code scanning is CodeQL. So CodeQL is very important in the security ecosystem, because you'll be able to go in and query using a database of security vulnerabilities and see if your code base is actually vulnerable to, let's say, cross-site scripting. So I'll show you how you can be able to use CodeQL within Visual Studio Code as well. And so the thing with CodeQL, it's within the GitHub Advanced Security toolset. So GitHub Advanced Security will check for dependency management. It will check for code scanning, and as well as secret scanning as well. So I'll also show you how you can be able to do that within GitHub. So let me share my screen. So a particular vulnerable application that I like using is the Django application. So this is a deliberately, purposefully insecure web application, which you can be able to go in and play around with. So at least you can be able to understand like the OS top 10 vulnerabilities in real life, and as well as infrastructure security, vulnerabilities. So what you can be able to do as a developer, remember we say that you want to identify security vulnerabilities as early on as possible. So what you do, you go to the extensions. So the marketplace is full of security tools. So we have commercial tools, let's say like Veracode, which you can be able to use within your IDE to scan for security vulnerabilities. We have Sneak as well. You can be able to go in and do security code scanning, dependency scanning, infrastructures code scanning as well. And for the security researchers as well, what I like using, as well as developers, you can be able to use CodeQL, install the extension. And then the good thing with CodeQL, as you can see here, we have a CodeQL security queries. So you make sure that you download or import these CodeQL security queries. And the way CodeQL works, it will analyze your code in the form of a database. So it will, you'll have to go in and import the CodeQL database. So you can import the CodeQL database from a folder, from archive, or from a URL, or from GitHub. So the way I like doing it personally is you can go in through GitHub and search for input your repo and see if you can be able to download your database. And then after that, you can be able to run it against the queries, the security queries that is built by the community against any security vulnerabilities. So remember, you can go in. We have very many extensions that you can be able to use. Let's see. Can people see there are very many? So what you can do is go in and see which one works best for you. You can see very well that we have hundreds and hundreds of extensions that you can be able to use for security review. But remember as well, you have to be very careful of the extensions that you are installing, because I've seen scenarios whereby there was an incident whereby someone installed a vulnerable extension was installed on Visual Studio Code, and a number of people who use that particular extension were actually compromised. So that one was more of a Bitcoin that was stolen through extension. So there's a lot of vectors that can be used by hackers to compromise your systems. So you also have like typo spotting, whereby like you are probably using a particular extension and then someone goes in and creates an almost similar extension, but just puts like a particular dash within the name. So you'll definitely find if people who don't do the due diligence, they'll be able to install the vulnerable extensions. So you have to make sure that you're always using verified publishers to make sure that you are using legit extensions. Due diligence is the word. And then we'll go in and I'll show you how you can be able to deploy for today's demo. We're going to use very simply how you can be able to use Defender for DevOps to be able to automate all your processes. So the way Defender for DevOps works, it has combined several open source tools. So at least you can be able to go in and not worry about deploying all these tools on your environments. So the one thing that I've seen within DevSecOps, like people are so quick in getting their environment, in getting so many tools within the environment. So you get a lot of noise within your environment, and then you might overlook a particular vulnerability and think of it as a false negative. And in such a scenario, you just overlook it and you find that it is actually a legit vulnerability. So the good thing with Microsoft Defender for DevOps, it combines all of those tools and it gives you a bird's eye view of your security vulnerabilities. Let me log in. Remember, you can ask questions. It can be even as simple as how can you be able to start off in the DevSecOps journey? Does it actually pay to be a DevSecOps engineer? What tools can you use in your environment? You can ask any of those and we're happy to answer. Okay, so for today, we're going to look at how you can be able to deploy Microsoft Defender for Cloud within Azure pipelines, Azure DevOps. So we have a marketplace here. Remember, just the same way as Visual Studio Code, we can go to the marketplace and you find there are very many security vulnerability security tools that you can be able to use. Let's see, we have Sneak, ADO security scanner. We have very many of these. So for today, in order for you to use Microsoft Defender for DevOps, you have to use the Microsoft Security DevOps extension. And then you see, get it for free. And then you choose the organization you want to go in and install it in. If for us it's already installed, so I'll just go to my DevOps. So as we said earlier, you can install this vulnerable Django application for you to have an overall view of the OWASP top 10 vulnerabilities. And then when you go to pipelines, and then you can create a new pipeline. And then you have to identify where your code is actually sitting. So for us, we'll be using our vulnerable application. And then we'll use a startup pipeline. I just want to show you how easy it is for you to be able to deploy the Defender for DevOps extension. And then so you go here to show assistant, and then you search for that particular extension that you have installed, which is the Microsoft Security DevOps. So if you want to leave it as is, you can leave it as is as well. So there's already a predefined policy that's created by Microsoft that will capture all those security vulnerabilities checks. So we can just leave it as is, and then you add it. So it will add a task called the Microsoft Security DevOps, and then you can run it. So I had already run it. We had already run it beforehand because it surely takes a bit of time. So after you have run the particular extension for Microsoft Defender for DevOps, it will come in and it will give you security vulnerabilities against your code. So remember we said that you have to look at credential scanning, you have to look at code scanning as well, infrastructure as code scanning. You have to make sure that you have to check all the components within your environment for security vulnerabilities. And I'll repeat, because we want to make it very hard for attackers to compromise the system, because if you leave one entry point for them to enter and compromise the system, they will use it for sure. So after you run, it will find all these errors and warnings. So if you go to this tab for scans, it will give you a breakdown of the security vulnerabilities it found. So here you can find, you see that there's Microsoft/SDL check. So Microsoft has the SDL checks, which can go in and find security best practices. We have this. So it published the Microsoft Security Development Lifecycle practices, whereby you can be able to go in and practice all of this. So you have to provide training for your developers. You have to define security requirements, define metrics as well for compliance reporting, perform threat modeling, establish design requirements. It gives you the list of tools as well that you can be able to go in and play around with. And then it also looks at CredScan. So it uses CredScan for credential scanning. And then it found that we have secrets within our code base here. And then it also found that we have like even S3 client secret, access key, general passwords as well. And then we also have TerraScan. So we use TerraScan is an open source tool that you can be able to use to scan your infrastructure as code. So you can go in and do this practically. I'll also provide a link to a workflow, a workshop that I published on my repositories. You can go in and be able to play around with all these tools. And then we're also using Bandit. So Bandit will be doing the SAS scan. So SAS scan, remember we said, is the static application security testing against your code to see if it has security vulnerabilities. And then we have the template analyzer, it's another open source tool that will go in to make sure that you're using templates that are actually secure. Let's say if you have like an ARM template that you're using, which will go in and make sure that you're deploying secure templates. And then you also have Trivi. So Trivi is an amazing tool that you can be able to use to find furthermore misconfigurations, S-bombs in containers, and as well as Kubernetes and clouds and more. Like it's an amazing tool that you can be able to go in and play around with. So as you can see, it checks for container image, file system, Git repo, virtual machine images, Kubernetes, AWS, and it will give you the security vulnerabilities that are found. So you can be able to do the same thing on GitHub. You just go in and create a workflow. And then you give one for Defender for DevOps. And then you provide a sample code of how you can be able to import the Defender for DevOps analyzer. And then once you hit run, it will do an automatic check against your environment to see if you have any of those security vulnerabilities. So once it has run, it will go in and give you the security vulnerabilities down here. So if you are new to GitHub Advanced Security, you have to make sure that if you have a public repo, GitHub Advanced Security will be able to work for your public repos. All you have to do is go to your security tab and enable the security checks there. So once you've done that, I want to show you how you can be able to bring the whole of that together within Defender for Cloud. So the good thing with Defender for DevOps, it covers everything within your multi-environment. So when you go to environment settings within Defender for Cloud in Azure Portal, you can be able to add, if your code is sitting in AWS, in GCP, in GitHub, and in Azure DevOps, you can be able to import all of those or integrate all of those environments to secure all of them, to have a bird's eye view of everything that's happening in your multi-cloud environment. And then once you do that, you'll be able to see where all your subscriptions are down here. So you can see for me, I have like Azure subscriptions, and I have I've imported GitHub connectors and Azure DevOps connectors as well. So we want to see the big picture, like how we can be able to have the bird's eye view. Remember, the Defender for DevOps integrates 6 tools, 6 open source tools. So how can you as a security person have or analyze security vulnerabilities? So that's where we have workbooks. So with workbooks, it will give you an overall view of a security posture in your multi-cloud environment, in your multi-pipeline environment as well. So when you go to workbooks, anytime now. So when you go to workbooks, can be able to import and use, you can create your own workbook as well. And you can be able to even use the predefined ones that are here. So for the Defender for DevOps one, you'll use the DevOps security. And voila, it will give you your security posture throughout all those environments and repos. So depending on the environment that you have integrated, it will tell you, we have several tabs. So for security, it will show you where all these exposed secrets are. And then for code scanning, if you have issues within your code, we said we are using Bandit for security scanning. It will give you your security vulnerabilities. And then it will also say, give you the severity, and it will also give you a remedy, how you can be able to remedy that particular security vulnerability. And then you also have open source vulnerabilities. Remember the borrowed code that you also have to make sure that you know what is vulnerable within your repos. You also have infrastructure as code, and then also giving you your security posture, and also some bit of threat intelligence within the threats and tactics that you can be able to deploy. So finally, I will show you the S2C2F. So this is a framework that you can be able to use to deploy secure supply chain consumption within your organizations. So when you go to this repo and go to these particular specifications, it will give you a drop down of the best practices that you need to deploy within within your environment. So they suggest having these 8 practices. So the first practice is ingesting that particular open source component. And then you have to make sure that you scan that open source component that you want to use for known vulnerabilities. And then you have to make sure that you inventory it. As I said, you have to know all of the components that you are using within your environment. You can see here, they said that for log4j, because it was using everywhere, it was just everywhere. It was a nightmare for security teams to patch that, because most of them didn't know which components are actually vulnerable. And then you have to make sure that you're always updating your components if there are any security vulnerabilities. And you always have to make sure that you're auditing it to make sure that if there are any vulnerabilities that are released, make sure that you're always keeping it on the know of what's happening. And you have to make sure that you enforce an open source security consumption within your organization. And then you always have to make sure that you also rebuild it. So from source code, every OSS artifact. So make sure that you are rebuilding your source code securely as well. And then the last one, you make sure that you fix it. And I think that one gives you an overall view of how you can be able to deploy the supplies, secure supply chain consumption. And then it also has levels. So depending on the scale of your organization, you can be able to deploy level 1 to level 4. If you want to deploy in-depth open source secure supply chain verification, you all have to do all of this all the way to level 4. And that brings us to the end of the presentation. And I will share with you the resources so at least you can be able to go in and play around with the resources, with the tools in mind. I'll also share this link so at least you can be able to go in and do it practically. And then if you have any questions, you can reach out and we can be able to do a demo event for you and your teams and how you can be able to adopt these best practices. Laura? So let's see.